Welcome to Creative World. In this video, we will solve Chapter 3 exercise problem number 3.18. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 3.18. Use nodal analysis to find the value of voltage V0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find voltage across this 2 kilo ohm resistance labeled as V0 with this specified polarity. And we have to use nodal analysis technique. So without wasting time, let's proceed towards the solution of the network. We know that in order to apply nodal analysis on any network, we have to follow some steps. First step includes finding out the maximum number of node voltage equations that can be retrieved from that network. So using this equation, we can find out that figure. In this equation, n represents number of nodes in the network. In our case, there are 4 number of nodes, so 4 minus 1 will be equal to 3. So maximum 3 number of node voltage equations can be retrieved from this network. In second step, we have to label all unknown non-reference node voltage. So these three non-reference node voltage are labeled as V0, V1 and V2. This V0 is appearing across 2 kilo ohm resistance with respect of this ground or reference node. So whatever the value of voltage on this node will be, same value will be appearing across this 2 kilo ohm resistance, and we are interested to calculate the value of voltage across this resistance because it is asked in this scenario. So our main focus will be to find out this node voltage. In third step, we have to assume all unknown branch currents along with their directions. Now we will apply one by one Kirchoff's current law on these three nodes to find out their node voltage equations. If we observe on this node, there is a voltage source connected. The negative of voltage source is grounded or connected to reference node, while the positive of voltage source is connected to this node 1. So we can say that whatever the value of this voltage source will be, same voltage will be appearing on this node as well. So from this point we can conclude the value of V1 that will be equal to 12 volt. So we have the value of V1, so there is no need to apply Kirchoff's current law on this node to find out its voltage equation. We will apply Kirchoff's current law on this node. On this node, only one current is entering while two currents are leaving. So entering current is 2 milliampere and it is taken with positive sign, while leaving currents are taken with negative signs, and these currents are I1 and I3. In next step, we have to replace these two currents with their respective equations. Current I1 will be equal to the potential difference of these two node voltages divided by the value of resistance. Direction of current I1 is from this node to node 1, so this node voltage will be considered as higher than node voltage V1. That's why we have subtracted V1 from V0. So current I1 will be equal to V0 minus V1, that is equal to 12 volt divided by 1 kilo ohm. Current I3 will be equal to V0 divided by 2 kilo ohm. Now in order to omit all denominator values, we will multiply this equation on both sides with 2 kilo ohm. Product of 2 kilo ohm and 2 milliampere will result 4 volt. Here product of 2 kilo ohm and 1 kilo ohm in denominator will cancel out with each other, only 2 will left, and that 2 will multiply with V0 minus 12 volt. Here the product of 2 kilo ohm and 2 kilo ohm in denominator will cancel out with each other, only V0 will left. Now open these brackets and multiply 2 with variables inside the brackets. The equation will become 4 volt minus 2 V0 plus 24 volt minus V0 equal to 0. Now add 24 volt and 4 volt together and sum of the minus 2v0 and minus v0 will become minus 3v0. Place minus 3v0 on the other hand side of equal to make it positive and separate it from constant value. The equation will become 28 volt equal to 3v0. Now in order to find out the value of v0, divide on both sides with 3. So the value of v0 will become 9.33 volt. So voltage across this 2 kilo ohm resistance, which is labeled as v0 with this specified polarity, have the value of 9.33 volt. So it was all about chapter 3 exercise problem number 3.18. Thank you. See you again in next video.